Hello, and welcome to this Hybrid Ag webinar. My name is Paul Bigley. I'm a member of the Hybrid Ag's leadership team, and I'm excited to introduce this Bud and Flower Optimisation webinar, which is the second part in a series of events scheduled for this year that will include a host of activities, including orchard walks, field trials, and observations that will take you on a graphic journey through the season, looking deep into the technical aspects and scientific facts about soil health and plant nutrition. We know you're all busy, but we think there is a significant value in taking time to take a step back from our businesses in order to better understand exactly what is happening in your soil and in your plants in order to optimize the outcomes you need: healthy soil, healthy plants, nutrient-dense food, and of course, bigger profits. Hybrid Ag are on a journey to understand more about how we can transform food to have a positive impact on human health. That is our purpose: transforming food for health. And we're on this journey to discover more about what makes food truly nutrient dense. We've begun collaborating with researchers all over the globe to collate research from the last 100 years in order to enhance the industry's understanding of soil and plant nutrition so that we can present this in a meaningful way to growers. Today, we'd like to start sharing that with you. Many of the subjects that we will be covering will be of a technical nature, and we don't make any apologies for that. We will try to present these subjects in a way that's easy to understand. But if anyone would like to discuss any aspect of any of our events or their contents, then I would encourage you to get in contact with us, where we'll be delighted to answer as best we can any questions you may have. I'd now like to introduce you to your presenters today. Jo Grace is one of our leading soil and plant nutrition specialists. Jo works in pome fruit, stone fruit, cherries, potatoes, berries, nuts, and citrus. He's added significant value to growers over the past 3 years, creating custom soil and plant nutrition programs for Hybrid Ag. Jo has a highly technical understanding of the chemical and biological aspects of soil and plants. We also have Andrew Smith. He's a fruit grower and a soil and plant nutrition specialist. Andrew works in cherries, stone fruit, pome fruit, table grapes, and citrus, and he has enjoyed over 35 years running his family's stone fruit business. Andrew's family have been growing stone fruit for over 150 years, and he has been working with Hybrid Ag for over 8 years as one of our leading tree fruit specialists. And me, Paul Bigley, I'm responsible for the company's sales, commercial, corporate operations, and our certified partner program. So Andrew, can you kick us off and tell us what we'll be focusing on today?
Thanks, Paul, and welcome everyone to today's webinar. There's been a great response, and we trust you will get something out of the group session we're holding today. So just to put the topic into context, I want to explain exactly what phenological stages we will be focusing on in today's webinar. There are 6 stages of nutrient importance in the tree cropping cycle, and this is where nutrients play critical roles in achieving the tree's maximum genetic potential. The specific nature of these stages change between crop types, however they can be grouped into broader categories. These are as follows: bud initiation, senescence, bloom, pollination, cell division, fruit fill, and ripening. Clearly understanding the role and balance of nutrients is highly important throughout these stages. Therefore, it is critical to understand the differences between the nutrient requirements during these stages, so the tree-specific nutrients needs can be addressed. High-quality fruit and consistent yields come when trees experience no deficiencies across these particular stages. This webinar today will focus on bloom, pollination, and the cell division stages. So our topics that we will cover will be stages of influence for nutritional management of the reproductive, growth, and dominant states of a tree crop. We'll give a basic overview of tree function through the flowering, pollination, and cell division stages, while also focusing on nutritional management practices required to maintain a reproductive state in the tree. Towards the end, we will have a summary with some grower take-homes on the topics discussed today. Now, if you have any questions, please feel free to type them into the Q&A box at the bottom of the screen, and we'll endeavour to try and answer the questions at the end of this webinar. There will also be a summary document with the information presented from today's webinar available for download following it. As part of Hybrid Ag's journey, we feel that we have a moral obligation to growers by delivering scientific information in a grower-friendly way in order to help grow their crops. I'll now let Joe explain the stages of bloom, pollination and cell division, so sit back and enjoy the information on these topics.
Thank you, Andrew. Good morning, everybody. So we'll start off by talking about flowering, and flowering is arguably one of the most critical stages in the season. So we're talking about the stage from white root movement, so very early in the season, through to fruit set. So interesting to note here that many issues that we can come across later in the crop can be attributed to problems during bud initiation, flowering, or cell division. So during this stage, two very critical outcomes are determined in the crop. Number one, the total number of pieces of fruit that will have the opportunity to make it through to maturity. And number two, the number of cells within each piece of fruit, which can directly influence fruit size and firmness and weight at harvest. So our goal at this critical point in the phenology of the crop is to increase our yield potential through better fruit set, cell division, and increase the weight and size of each individual piece of fruit. So this is where we get to an interesting principle here that comes up that we know as managing yield loss. So every variety, every crop has what's known as a genetic potential for production. So any management intervention or climatic condition that influences that crop during the season will have one of either two outcomes: conserve the yield to the genetic potential or reduce the yield of that genetic potential. We can never increase above that potential. So firstly, to understand what we're trying to achieve, we need to understand how different nutrients can affect plant hormones. Many of us will be familiar with auxins and gibberellins and cytokinins as the major hormones in the plant, and how plants are able to exert both reproductive and vegetative, or feminine and masculine characteristics. And these are mainly controlled by the production of predominantly cytokinin and auxin hormones within the plant. What's perhaps lesser discussed is the fine balance between these two functions. So in a plant which is growing quite strongly and not setting heavy fruit loads, we don't necessarily have a situation in which we have a 90% dominance of auxin and 10% of cytokinin. It's more likely to be closer to a 45-55 ratio, so very close. But a 5 to 10% shift either way becomes very, very apparent when we're looking closely at plant behaviors. So during flowering and fruit set, the plant is biased towards reproduction, but immediately after cell division, which happens directly after pollination, once cell expansion begins, the plant is now slightly biased towards vegetative growth. So it's also during this stage when a plant is switching from reproduction to vegetative dominance, or vice versa later in the season, that the plant is at its most vulnerable point to disease or pathogens or insect attack, which we know because the majority of the plant pathogens that affect tree crops, or a large amount of them, have their initial infection either during flowering or very shortly after flowering, or during bud burst. So nutritionally, the responsibility at this stage of the crop is to ensure the plant has the energy that's necessary to make this switch as quickly and as smoothly as possible to minimize the stress on the tree. So the basic nutritional requirement is to ensure we have availability of the nutrients which encourage all of the nutrients, which encourage cytokinin production and reproductive dominance in the tree. The main aim of any application before, during, and after, or shortly after flowering, is to enhance the reproductive function of the plant, because we're trying to set up the crop that we're going to harvest. So having these nutrients available establishes an environment for the plant which has an adequate nutritional density during this period, and ensures the most effective cell division, which we'll come to shortly, which is one of the most crucial parts of setting up the quality of the fruit. So you can see on the scale on the slide here, we have some nutrients to the right. So we have nutrients there, some examples of some nutrients there that influence the crop towards a dominantly vegetative response, and nutrients to the left, which will influence the crop to a dominantly reproductive response. So if you look at the nutrients on the right, for example, we have potassium, chloride, and nitrate nitrogen, which most of us will be familiar with these as being associated with growth and maybe fruit size in the tree, or just general vigor in the tree when we apply anything with these nutrients in them. So obviously during flowering and fruit set, we want to avoid applications of these nutrients on the right side of the scale. And if we look at the left side of the scale, we have some other examples. So manganese and phosphorus. We have nitrogen, but it's the ammonium form of nitrogen, and sulfur. So these have a synergistic relationship with cytokinin production in the tree, whereas the others have a synergistic relationship with auxin production. So understanding this hormonal balance within different nutrients, or the influences that they create, allows us to make some informed decisions about nutrient input management during flowering. So for example, if we were to apply nitrogen around flowering, we'd want to ensure that this is in the ammonium form, so that we don't fundamentally upset the stages that the plant's going through there. So another one, if we're going to put on calcium at this stage or before this stage, we'd probably be looking at a calcium sulfate, for example, or gypsum, or if we're going to apply some foliar calcium, it would want to be a chelated calcium rather than a nitrate, for example. So another interesting point here is, I'm sure you will have noticed the calcium being in the center of the balance. So calcium is an interesting nutrient in which it can be present on both the vegetative side and the reproductive side. So for example, calcium can provide a lot of energy to the plant, but it is also critical for cytokinin production. So we need it on both sides. And it's also well shown in studies, in foliar studies, that calcium must be available in the soil and from the roots of the plant for foliar applications of any nutrient later on to be effective in the crop. So this then brings us to I thought we'd do a little bit of discussion on calcium, dedicate a bit of time to calcium, because it's often a common question that we get is, why do we recommend to apply calcium so early in a lot of our recommendations? So I thought we'd just demonstrate here the role of calcium in one of the most critical functions early during this flowering period. So I stated earlier that flowering was arguably one of the most important periods of the season, and to achieve any outcome from flowering, we need to have successful pollination. So here we can see at the top left-hand corner there, we have a grain of pollen, which has been released from the anther of a flower. And then at stage 2, this piece of pollen has actually landed on the stigma, which is the center part of the flower, of a compatible flower, or a compatible variety. So here, the stigma is actually moist, so that the pollen absorbs moisture and starts to swell. And then we have an enzymatic process that begins breaking down the wall of that piece or that grain of pollen. The other critical thing you'll notice here, and I think it's stage 4 there, is the supplementation of calcium that the stigma provides to that pollen grain. And it's been shown in laboratory analysis of artificial pollination that without this supplementation of calcium and also boron, boron's not listed on this graphic, but also boron is critical to the next stage of pollination, which is the pollen germination. So having that calcium availability to the host flower is very, very important to actually getting to that next stage of pollination where we can get fruit set. So you can see the pollen germination is very similar. An easy way to think of it is as a seed germinating. You can see and down the bottom left-hand corners here, the pollen is beginning to germinate, and it's growing a root-like structure out of the grain. So in the next picture, we've got a cutaway of a flower. So this is the host flower that has had the pollen on it, and so you can see the pollen has then begun. That root-like structure we saw in the last picture is what we call a pollen tube. And that has begun growing down the center of the flower, which is known as the style. And it grows down the center of the flower towards the ovules, which are at the base of the flower, where the fruit finally will set. And you can see on the right-hand side a blown-up picture of the tip of that pollen tube as it's growing down the center of the flower. So you can see at the top right-hand side of that is an arrow with some calcium ions depicting the flow of calcium ions from the host plant into the pollen tube as it's growing, which the pollen tube requires this input of energy to continue its growth down the center of the flower. So if this host plant does not have adequate supply of calcium at this stage, the pollen tube doesn't make it down the flower, and so we never get fruit set. So the next one is just a graph of calcium uptake during the season. So this is from sap analysis, which we have taken through the season on stone fruit, this one. And here you can see the majority of calcium is taken up very, very early in the crop cycle. So from our data on this data set, we calculated that approximately 60% of the calcium removed by that crop has already been absorbed by the fruit by a small fruit stage. So you can understand also why calcium applied late in the season rarely ever fixes fruit disorders if calcium is low during the early stages of the crop. So next we have some other trace elements which are critical for this period. So obviously these are 6 key elements which we believe are critical to having successful flowering, pollination, and fruit set and cell division. So manganese is required for the plant to be able to regulate potassium, which is very, very important at this early stage. Potassium and calcium are very, very antagonistic of each other. So the plant actually requires manganese to be able to regulate potassium flow in the sap. And so having good levels of manganese at this stage allows the plant to regulate potassium flow and allow calcium into the fruit, which is a common, probably one of the most common problems that we see during flowering is that relationship there. Zinc, one of the major functions of zinc is in the cell membrane production and maintenance, and also in protein production. So it's critical to have it in this period to have it in combination with calcium at this period for cell division. And then boron, we saw the importance of boron earlier in the pollination stage. So, and then it's also very well known boron's relationship with calcium, and obviously calcium being very important at this stage, we need to make sure that that's available. Phosphorus is an integral part of what we call ATP, which is effectively the plant's energy transporter. So like you could think of it as the fuel that the plant runs on from produced by photosynthesis. And this makes phosphorus important for nutrient distribution through the plant because it forms proteins which convert other nutrients into usable form. So very important for getting other nutrients into the plant as well. Cobalt's one here that's probably not talked about very much, but to have cytokinin production in the plant, we need to have growing root tips because this is where the cytokinin hormone is produced in the plant. It's always produced in a growing root tip. So, or the majority of it is. And we need cobalt to actually help, or cobalt stimulates that root tip growth. And the plant will be using, although it's only a small amount, the plant is using cobalt at this stage, which is something that, in high pH soils is probably not available. And then we don't often think about adding small amounts of cobalt. So it's probably one of those ones which is probably not often available. Copper, very important for the pollination process because it's required in that pollen tube formation. So also later in the season, copper is required, or copper gives the cells, or is important for cell elasticity. So think about cracking and splitting of fruit later in the season. In a lot of cases, having better copper levels in that fruit to begin with can actually help the fruit have some more resilience to this later on. Seaweed, obviously not a nutrient, but a source of already available plant nutrients. So nutrients that have already been processed by a plant. It can also help supply what we call secondary metabolites, which is sugars and amino acids produced by the plant through the plant's various functions. And it helps to maintain that production of cytokinin in the plant, which is important during this stage. So then we have cell division. So after we've had flowering, we've had pollination, we then move straight into a period that's about 10 to 14 days that we call cell division. And this is where every cell that will be in that final piece of fruit is created. So the cells go through a process of constantly dividing for a certain period of time, depending on different environmental conditions and nutrient availability. So it's important to understand that each piece of fruit on the tree does not have the same number of total cells. The total number depends on a number of factors during this period. And so climate can affect that, water availability can affect that, nutritional integrity of the plant and what's available to it can affect that. And it can either, the nutritional applications during this period can either increase cell division or hinder cell division. So that's where we come back to that managing yield loss. We don't want to do anything that is going to hinder it. So calcium being critical to the cell wall function is one of the, in a lot of cases, one of the major limiters to how much cell division or how productive that cell division period is, because calcium required in the cell wall of every cell that's produced, it needs to be there during this period. So extending this period, doing anything that we can to extend this period, which includes having all of those nutrients available that we need, using things like seaweed and whatever with our applications, is very, very relevant to the ability to produce large, firm fruit with high density, which is directly related to the quality of the fruit at the end of the season. It's interesting just to give you an idea of how early this happens in the season and how quickly it happens. There's some studies that actually estimate that 50% of cell division for that crop may have taken place, or for a particular crop, may have taken place by the time we recognise the stage of full bloom. So it happens very, very early and very, very quickly, which emphasises the importance of that early nutrient and water availability. So I think I hope that explains a little bit about calcium and some of the trace elements that are vital during that period. And we've got Andrew's going to give us a practical example of cell division in some cherries.
Thanks, Joe. That's some great information there to digest. By the way, keep the questions coming in. I see there's a couple coming in, so we'll try and endeavour to answer them later on. So just to give a practical example of cell division in fruit, we have a picture here up on the screen which shows an actual cherry cell, which is going through the cell division stage. What we're trying to do here is maximise the potential of cells in the fruit. So as you can see here, we've got a genetically smaller cherry, which has less cells, and we've also got a cherry on the right, which has got more cells, which gives it a better genetic potential to grow to a larger size. So with the more cells per cherry or other fruit type, you can achieve better size of your fruit and increase your fruit firmness and fruit weight actually at harvest time. The cell density in fruit is a direct correlation to the fruit's shelf life and storage ability. This is a process nearly identical in other tree crops and varieties. So you can see this is where you as a grower can help influence your fruit quality during this critical stage. So managing effective nutrient applications are made possible by understanding these processes within your specific tree crops. It's important to know when each of these physiological stages are and what your soil and tree nutrient levels are actually doing. By using this knowledge, your tree nutrient inputs can be managed much more accurately. The right nutrients need to be available at the right time. Effective management includes soil remediation with the appropriate nutrients, maintaining testing practices in both soil and leaf to ensure any deficiencies can be quickly diagnosed and addressed. It is important to remember that the overall goal of nutrition management during the time of bloom, pollination and cell division is to supply the nutrients that are critical to this reproductive function. Good levels in calcium and trace elements are key during these physiological stages. So in summary, during bloom, pollination and the cell division stage, trees shift into what is known as a cytokinin hormone functioning or a reproductive state. Trees' calcium needs to happen much earlier than we have thought, due to the requirements through the pollination and fruit set stages, particularly as Joe explained, in the pollination stage, it's critical that the calcium is there. Nutrient management should be targeted through the appropriately met to meet the tree's reproductive needs of the tree crop cycle. Nutritional application should be targeted to focus on cytokinin production. I can't stress enough that we really need to maximise the cell multiplication stage, as this will be the best possible size and firm fruit that you can actually produce at harvest time. So what are our actual grower take-homes? So our key points of grower take-homes from today's discussion is calcium should be applied a lot earlier via either fertigation or foliar to maximise bloom, pollination and cell division stages. When applying nutrients via the ground or by foliar, they should be corrected to try and induce a cytokinin dominance or a reproductive form in order to maximise the bloom, pollination and cell division phase. Trace elements have a strong role to play during these stages, so when foliar applying trace elements, they should be in a chelated form, or if they're going to be as a sulfate form, we need to combine them with either a fulvic acid or a seaweed product to minimise the oxidising effect. Finally, avoid using growth promoting nutrients until the tree has actually finished using its cell division phase and has moved into the actual cell expansion and fruit fill stages. So just to recap, the document from today will be presented and distributed for download after this webinar. Once again, thanks for listening, and back to you, Paul.
I see there are already some great questions, which we'll get to shortly. But before that, just a heads up about our next webinar. We'll be following on from today's discussion discussion covering the stages of fruit fill and ripening. This webinar will be happening in September, and we'll let you know the date as soon as we can. Also, if you have any feedback from this webinar to help us improve, then I'd love to hear from you. I hope you found that interesting and informative. Now, we've received some interesting questions during the webinar, too many to cover here. So Andrew and Joe, can we please answer some of the most interesting and relevant questions now, and then we'll send out the answers to all of the other questions on an email after this webinar. Joe, is there a specific question that you'd like to tackle first?
Just had a question come through on calcium chloride, actually. So there's actually been two questions the same or similar here. I'll read the longest one. We use a lot of calcium chloride through the season, but still experience bitter pit in some varieties. Why is this? And the other question was calcium chloride applied during flowering. So interestingly, there's been a lot of global research on calcium chloride applications, and a lot of it suggests that calcium chloride actually doesn't translocate into the fruit very well because of the energy that it takes to be converted into a usable chloride. So into a usable calcium, sorry, into the phloem. So, and then the other side of that is also some research suggesting that the calcium chloride applied on fruit can in some cases cause a burn in some environments, which looks very similar to bitter pit or lenticel breakdown, which we commonly associate with a calcium deficiency. So the other part of, just to look at lenticel breakdown or bitter pit quickly, is in most cases, it's not due to a lack of applied calcium. In most cases, any grower that's experiencing bitter pit issues is applying more than enough calcium throughout the season to supply what the plant needs. Where the research has got to, as far as we're aware of, and as far as our experience in this area, is that it comes down to potassium excess during flowering and during that early stage of growth that is holding out. Obviously, potassium, as I did mention, potassium and calcium are very antagonistic of each other, and you can have elevated levels of potassium during flowering, which is holding out that calcium from getting into the cells during cell division. And so we end up with weak cells being created. The key to that so far has been manganese availability. The plant requires manganese to regulate potassium in the sap flow. And so it's an interesting, it kind of goes around in an interesting circle where you look at the calcium deficiency late in the season is not necessarily due to a lack of applied calcium, but it's due to an excess of potassium, which is caused by a deficiency in manganese during flowering. That answers the question some way.
Oh, that's great. Thanks, Joe. Andrew, is there a question that you'd like to answer?
Yeah, there's some really good ones here. This is probably pertinent to today's discussion. There's one here that says, when do I know when cell division actually finishes? So there's no actual real universal way to understand that, but it's really typically 14 days post full bloom. Probably an in-field way would be to, particularly in stone fruit, get a piece of fruit and cut it open and just see where you're at based around that stone hardening process. Once you start to see that stone starting to solidify, that's typically when the cell division stage is finished, and that's when the tree will be moving into its growth stage or cell expansion phase. So I hope that answers that question there for you, Paul.
That's great. Thanks, Andrew. Joe, I think we've got time for one last question. Is there another one that appeals to you?
A good question here from Terry Young is, can we apply the same principles to legume or broadacre crops, peas, vetch, etc.? Absolutely. So the same principles apply almost directly across any fruiting crop. So any crop that flowers and sets fruit is very, very similar. Some ones that are different is things like potatoes, where the tuber is not actually a fruit of the plant. But yeah, any of those other crops, grain and peas, etc., corn, all very similar. You can actually do corn is one where there's a lot of study being done on this worldwide, and there's certain periods in the crop you can actually influence the number of kernels and the rows and the columns. I think I'm not actually sure what they call it. Basically the number of kernels on each piece, on each cob, can be influenced at certain periods in the crop. So that's a very interesting one to look at.
Thanks, Joe. If you haven't asked a question today but would like more information, then please do not hesitate to drop us an email or give us a call. All of the questions and answers from this event will also be available through our certified partners, who are David Morello at Morello Fert, Noel Jans at Sahara and Elders, Craig Swansbury at Fruit Doctors, and Graham McNeil at GV Crop. I'm sure they'd be delighted to hear from you, and thanks to them for their continued support of Hybrid Ag. We'll be sending out a technical summary about today's topic to everybody who has attended today. And finally, thank you to all of the technical experts from around our industry who have helped bring you these events, but with special thanks to our very own soil scientist, Sarah Tinsley, who's pulled together this particular event so magnificently. Well done, Sarah. That's all for today. Thank you for joining us. Goodbye.